we're so excited about having 6 people on the station because until just recently we couldn't have crews larger than 3 up there. And that was because we couldn't get enough water up there to support a larger crew. Well, recently they got the water recovery system working, so now all the water that goes to the station stays on the station. We can now recycle wastewater and urine into oxygen and drinking water. Makes you thirsty thinking about that, doesn't it? Yum, yeah. The astronauts prefer to call it yesterday's coffee. Whatever works for them, right? Yeah, they're a real brave bunch, fortunately. And I'm going to introduce you to those guys in a minute. But right now I want to call your attention to this right-hand screen over here behind me. You're getting a live look into one of our Mission Control Center rooms across the street at Johnson Space Center. We have 2. Both rooms are called FCRs. That's FCR. NASA has an acronym for everything. That stands for Flight Control Room. One of them is the white FCR. It's the flight control room for the shuttle missions, and it's located just down the hall from this room. This is FCR 1, the flight control room for the International Space Station flight controllers. And you're looking at the back right corner of the room. They've zoomed the camera in here, but you are getting a great look at our flight director currently on duty right now. They're in the white shirt closest to you. That's Mr. Michael Lammers. The flight director is the leader of the flight controller team, and that position is manned 24 hours a day, 7 days a week, and has been for over 8 years. We have standing up back here, and she was over here a second ago. This is another one of our flight directors has walked in the room there. That's Miss Courtney McMillian, and she's not on duty right now, but she's certainly in there. Seated next to the flight director today is our Capcom, and that is Mr. Ryan Lean. The Capcom's job is to act as the communicator between the astronauts, in this case on the space station, and the flight controllers on the ground. Well, now I want to tell you how to tell the difference between a shuttle mission and a station mission. Shuttle missions are always the initials STS followed by a number that designates the mission. STS stands for Space Transportation System. Station missions are called expeditions. That's EXP followed by a number. And this is our Expedition 20 crew, but they're also made up of Expedition 19. So let me explain that to you a little bit. Until just recently, we had on the station only these 3 guys right here, if I can get my light to work. This is Gennady, he's a cosmonaut, and Koichi, a Japanese astronaut, and Mike, a NASA astronaut. By the way, a cosmonaut is a Russian astronaut. That's just what they call them. So those 3 guys were up there all by themselves as members of Expedition 19. And then recently they were joined by these 3 guys, another cosmonaut, a Canadian, and a European. And all together they make up Expedition 20. And I want to go ahead and introduce you to them, and then we're going to talk about this next space shuttle mission. So both Expeditions 19 and 20 launched to the International Space Station on board Russian Soyuz rockets out of Kazakhstan. And this is the first time that all 5 partner space agencies have been represented on the station, and the first time that we've got a crew of 6 up there. Commanding Expedition 20 is cosmonaut Gennady Podolka. He's a colonel in the Russian Air Force with a master's degree in engineering and ecology. And this has been his 4th space flight. NASA astronaut Mike Barrett serves as flight engineer. He is a medical doctor. He's also a former NASA flight surgeon for the International Space Station program. And this has been his 1st space flight. Japanese astronaut Koichi Wakata serves as flight engineer. He has a PhD in aerospace engineering. He is the 1st long-duration station crew member from Japan. Cosmonaut Romanenko serves as flight engineer. He's a pilot engineer. He is also a lieutenant colonel in the Russian Air Force. And this has been his 1st space flight. European Space Agency astronaut Frank DeWinna serves as flight engineer. He has a master's degree in telecommunications and civil engineering, and this has been his 2nd space flight. And Canadian astronaut Bob Thirst serves as flight engineer. He's not only a medical doctor, he also has master's degrees in mechanical engineering and business administration. He's a super achiever. And again, this is the first time that we've had all 5 partner space agencies represented by crew members on the station. The completed International Space Station will have 5 state-of-the-art microgravity laboratories, a habitable volume larger than an average 5-bedroom home, and over an acre of solar arrays. This crew is also conducting a full program of scientific experiments, and many of these are aimed at learning how humans function during long periods of weightlessness and what we need to do to keep them healthy in that type of an environment. The International Space Station is about 215 miles above Earth. It is orbiting Earth once every 90 minutes and traveling at a speed of 17,500 miles an hour. It has served as a laboratory and training ground for future missions to the Moon and eventually to Mars, and it will be completed in 2010 when the space shuttles retire. And then after the shuttles retire, we'll be using the next generation of NASA spacecraft. The Ares 1 crew vehicle Orion will transport crews to and from the station and the moon. There are 15 nations participating in the ISS program. Currently, it's 83% complete. It weighs 331 tons. It is larger than an average 4-bedroom home and has been constantly manned for over 8 years. That is 3,161 days as of today. It's an amazing facility. And of course, we could not have built the International Space Station without the use of a very sophisticated spacecraft, the Space Shuttle. Shuttles are actually moving vans or 18-wheelers. They're the workhorse for the space program. Most of the Space Shuttle is cargo bay. The cargo bays measure 60 foot by 15 foot. We have 3 shuttles in the fleet, Discovery, Atlantis, and Endeavour. They cannot go to the moon or to Mars, but they are very good at what they were designed for, and that is to carry really big stuff into space. Our space program is taking us back to the moon, and then we're going on to Mars, so we do have to have new spacecraft to accomplish that. Well, right now there's not enough money in NASA's budget to continue the rather expensive shuttle program and develop the new spacecraft program at the same time. So that's why the shuttles have to be retired. And of course the museums are fighting over who gets to keep them after they retire, and we're fighting too. So hopefully we're going to have a shuttle come live right here with us, and that'll make all of us around here very happy, that's for sure. We'll see. All right, here's the crew for this mission. They are so ready to go. You know, we missed 2 launch opportunities because of a problem with the hydrogen fuel line out there at the launch pad. And they think they have that problem licked. It was with a seal where the fuel line goes into the external tank, and they're going to test for that this coming Wednesday. So cross your fingers that that works. We do have a new launch date now, July the 11th, and this is our launch time, which is a better launch time than before anyway. I think they were going to be taking off like at 4:40 in the morning. This is not a friendly time to watch a launch. This is much better. And the crew is back in training. As soon as they came back here, which was like immediately after scrubbing the last launch attempt, they went back into training, and they do always continue training right up to launch time. This mission is the Space Shuttle Endeavour, and you can see we're scheduled to launch on the 11th. And we're going to deliver and install the final component for the Japanese laboratory Kibo and batteries for the P6 truss. Commanding STS-127 is Mark Polanski. He's a retired Air Force test pilot with a master's degree in aeronautical and astronautical engineering. This is going to be his 3rd shuttle mission. Serving as pilot is Doug Hurley. He's a lieutenant colonel in the Marine Corps with a degree in civil engineering. He will be assisting with robotics, and he will also assist with the EVA, or spacewalk preparations on this mission. Mission Specialist Dave Wolf is a medical doctor, and he also has a degree in electrical engineering. He's a veteran spacewalker already. He'll be conducting 3 more spacewalks on this mission. This will be his 4th space flight. Mission Specialist Chris Cassidy is a commander in the Navy with a master's degree in ocean engineering. He will also be conducting 3 spacewalks during this STS-127 mission. Mission Specialist Tom Marshburn is a medical doctor, and he's also a scientist, and he'll be conducting 3 spacewalks as well. There will be 5 spacewalks total conducted during this mission. Canadian astronaut Julie Payette will serve as flight engineer. She has a master's degree in computer engineering, and she will be the primary robotic arm or Canadarm operator. She's the robo chick, and there's a lot of robotics on this mission. And this is the arriving Expedition 20 flight engineer, NASA astronaut Tim Cogler. He's a colonel in the Army, and he's going to be traveling to the station with this crew. We're going to leave him there. He's trading places with Koichi, who you've already met. He's been up there since mid-March, so it's his turn to use the shuttle as a taxi to come back home. And of course, as always, our best wishes go out to the crew, and we wish for them a very safe and successful mission. Many of us who work here are privileged to get to watch the astronauts conduct some of their training. Also, many of us who live around here live near astronauts, and we do get to see them often in the grocery stores, and the restaurants, and the parks, church, and Little League, and around the neighborhoods. So anytime a mission goes up, there's a big piece of our hearts that goes up with them as well. And we learned a lot from the Columbia disaster. We can now thoroughly examine the shuttle's nose to tail after launch, and then again before landing, to see if it has sustained any damage that put the crew at risk on re-entry. And if they find damage, they can now repair that damage. We couldn't do any of that before Columbia. But they do have to plan for worst case scenario. What if a shuttle were damaged beyond repair? Then what do you do? When you're docked with the station, the crew moves from the damaged shuttle into the station. They use that as safe haven. They take enough provisions to live with the station crew for at least a month. And then we have to have another shuttle ready to move out to the launch pad to serve as a rescue mission to go to the station and retrieve the crew. Obviously, we don't plan to demonstrate any of the latter, but it is very comforting to have a plan like that in place. Now this mission will be the 29th shuttle mission to the International Space Station and the third in a series of missions to complete this huge Japanese lab complex. We're going to have 13 astronauts on board at the same time for the first time, and of course they'll be representing all the partner space agencies too. The first thing we're going to do is complete this Japanese lab, and we'll remove from the shuttle's cargo bay the external platform, which is also called the porch, there we go, and we're going to attach it to the end of the outside of the main lab module. Then we'll remove from the cargo bay the logistics module, which contains experiments, and attach it to the end of the external platform. And they'll use the Kibo robotic arm to move the experiments from the logistics module and put them on the porch. And then we can study the harsh environment of space effects on things. This logistics module will be going back home in the shuttle's cargo bay. Also during the spacewalks, the crew will be installing batteries at the far end of the station's 356-foot-long truss. The P6 truss was first deployed in 2000, and it was the station's initial power supply. Also, there's a drive unit for the mobile transporter and a boom for the KU band antenna that will be transferred to the external stowage platform 3 during the spacewalks. And then on the way home, excuse me, we've obviously done this before, we're going to deploy some small Pico satellites from Endeavour's cargo bay, and then landing is scheduled at Kennedy Space Center in Florida. But you know how that works. In case of bad weather in Florida, we do have alternate landing sites. And the first choice alternate landing site is Edwards Air Force Base in California, where the weather's almost always nice. But we can also bring them back home to White Sands, New Mexico. However, it is a whole lot faster and about $1.8 million cheaper to bring them back home to home base in Florida to start with. So that's why they always try so very hard to do that. Now, a lot of people wonder, well, what do you do here in Houston anyway? Well, one thing's for sure, we never launch from here, we never land here. We never have and we never will. All the shuttles have launched out of Florida, Cape Canaveral there at Kennedy Space Center, and we try to land them all there. Houston is home to mission control for the manned missions. We also have the largest astronaut training facility here. And so the astronauts, for the most part, live around here with their families while they're training. It's a great place to live, and a lot of research and development goes on here as well. Now, we all benefit every day, whether you know it or not, from one or more things just from the shuttle program. And to see this whole list, go online and put in Space Shuttle spinoff, and then Google NASA spinoffs, and you will have to use your imagination. But you can see how very different our lives would be now if the space program had never happened. That's a real eye-opener there. We do have some other exciting things going on. The two little rovers, Spirit and Opportunity, which were designed to last only 90 days, have now been on Mars for 5 years and 6 months, almost 7 months, and they're both still going strong. I'm going to show you the latest picture from each of them. Spirit is bogged down in the sand right now, and they say they'll be able to get it out. They've got it unstuck several times before, so I totally believe them. They're also learning a lot about that immediate area around Spirit while they work on getting it out of there, which is kind of interesting. Everybody wants to know when we're going to send men and women to Mars, right? That'll probably be about 20 to 25 years from now. So that means that at least 3 of you in here, and I can't tell about you, it's a little dark in here, but I think you qualify for this. Everybody who's right now between the ages of 3 and 20, and that's give or take a few years, is in the age group that NASA says will be the men and women who will actually travel to Mars. Well, does that include you too? Are you in that age group? Yeah. Is she?
Wait, me?
Yeah, you.
Oh, yeah.
Yeah, you are good. Well, I can't tell. You're just kind of dark and you look older, so it's like, I can't tell if she's over 20 or not. So how old are you?
I'm 11.
You're 11? Oh my gosh, you're 11. I'll be able to tell when the lights come up. Are you excited about the idea of being able to maybe go to another planet?
Yeah.
It's pretty cool, and it's absolutely amazing. But you know what? We're going to be sending crews back to the moon first. So why are we doing that? We already went to the moon, right? Well, for one thing, the president charged NASA with returning humans to the moon by 2020 and then going on to Mars by 2030. But these lunar missions will be very different than the Apollo missions. We will be building a permanently manned outpost on the moon. And of course, to get the crews and the equipment to the moon and to Mars, we have to have those new spacecraft. So you're now looking at very early design concept drawings of the new spacecraft. These are very much subject to change. The program is Constellation, and the rockets are named Ares. The big one is Ares 5. It's cargo only. It's a heavy lifter. This is Ares 1, and it'll carry the crew, which could be some of you, right? You just don't know it yet. You'll be in the new crew vehicle on the very top, and that's been named Orion. And I want to encourage you while you're here today to be sure to check out one of our exhibits in the plaza. It's the Constellation Program exhibit. And it's real close to the main entry doors where you came in, actually. It's right in front of that big gift shop. You can see how large that Orion capsule is, and then compare the size of it with the size of the Apollo 17 capsule in Starship Gallery. As you walk around this exhibit, it explains the process of going back to the moon. At first glance, it does look somewhat similar to the Apollo program, but it really is quite different. So be sure to check it out. I think you'll enjoy that. That's just some of what's going on at NASA right now, and I want to thank you for joining me in Blast Off. I do have available for you at the front of the stage, which you are welcome to pick up as you exit to your right. There's two little piles, and they are exactly alike. It's a list of websites that you can go to and get the answers to any questions that you might have about the space program, and I will also be available by the door just in case you have any questions for me on your way out. Enjoy the rest of your stay at Space Center Houston, and thanks again for joining me.
Thank you.